started this program based on American Center Colombo and American Center Candy. Our huge strength was American Center and American Embassy. Our objective is to create platform to share STEM-based knowledge among Sri Lankan makers and make them confident about their path and make their dreams come true. And also to build an innovative ecosystem between Sri Lankan. This is the most important person here. He is Ranjan Kulatunga. He is Senior Design Engineer at 24/7. He is the co-founder of this program. We are conducting Makerspace certificate courses, public seminars, outreach programs, exhibitions. Up to now, we have more than 10,000 makers gain knowledge from Makerspace. These are the programs we have conducted. Let's move to today's session. We are going to have an advanced text workshop series. Our series going like this. February, July, we are going to have these sessions. February, we are going to have machine learning for beginners, and March, we are going to have automated reality and visual reality. In April, drone designing workshop, and May, battle part designing workshop, and July, we are going to have your own automated car workshop, and July, we are going to have Industry 4.0 workshop. So then today you will learn about high-level introduction about machine learning. Next day, you will learn how to do the things with machine learning. So I would like to introduce Tilnayapa Bandara, our resource person. He is tech lead at 24/7. So on 24/7, he is certified trainer and BSc Engineering, Electronics and Telecommunication Engineering in 2010, and MBA, University of Sri Jayawardhanapura, 2016, and visiting lecturer at Rajarata University, ESOFT and Pioneer Institute of Business and Technology. Machine learning is a programming computers to do things by looking at the past data. If we look around, we can see AI everywhere, applicable in many areas such as language processing, medical diagnosis, image processing, banking, finance, and many other places. What is this AI? What is this artificial intelligence? And what is this machine learning? And what the relationship between this machine learning and artificial intelligence? Tilina, this is over to you.
Thank you, Nadi. Thank you very much. Thank you, ladies and gentlemen, for appearing here. Good evening, everyone. If you can hear me and if you can see me at the moment, I want all of you to put a chat saying yes. Let's see how many of you are here and here with us and enjoying this session. So if you are here, if you can listen to me, if you can see me, just put a chat. Thank you very much. I'm seeing a lot of enthusiastic responses. Thank you, Nadi, for that brilliant introduction, and thank you every one of you for being here. Now, we understand these are difficult times, isn't it? I mean, and the entire world is talking negative about these times. While the entire world is talking so much negative of this time, you have taken the decision, no, we are going to take some value from this. We are going to approach this time positively. So without just complaining about the time, how difficult the time is, you took a decision that you are going to come to this program and enjoy this program and learn in this program. Just like Nadi and the American Center has facilitated you, you are here to learn, you are here to grow, and you are seeing this as an opportunity. So all of you for saying yes, thank you very much for saying yes to this program. By saying yes to this program, you said yes to yourself. So kudos to all of you. Let's make sure that these 2 hours are going to be absolutely enjoyable, because I believe at the times of enjoyment, you learn most. You learn most when you are having fun. So how many of you are ready to have fun within these 2 hours? How many of you are ready to have a lot of fun? If you're ready to have a lot of fun, and if you want to have a lot of fun, just type fun in the chat box. Let's see how many of you are ready to have a lot of fun. Brilliant. Thank you very much. In fact, that is true. I mean, if you think carefully about how you learn, ladies and gentlemen, you will understand that you have learned best at the times of fun. So when you have fun, you learn the best. That's the type of learning culture that we want to inculcate here at American Center and in this set of programs. So thank you very much again for being here. And we are going to make sure that this set of series of programs are going to be filled with fun and a lot of knowledge so that you will go home with a lot of fun, at the meantime, a lot of learning. So you are here for a treat today where for saying yes to yourself. And this treat is going to be filled with learning and also a lot of fun. So we are going to make sure that we are going to have this session, which is enriching your lives while adding fun. And you will see and in a second a screenshot, and I hope you can see my screen. If you can still see my screen and still see my face and you can listen to me, everything, if everything is all good, just type all good. Let's see if everything is good to go. And it's fantastic to see more than 100 participants. And if I'm not mistaken, yeah, we have around 161, and I'm pretty sure there are a lot more joining. Brilliant. This is absolutely brilliant, absolutely gorgeous. By the way, Nadi asked a very fundamental but a very intriguing question, ladies and gentlemen. I mean, probably you also have this question. We have heard a lot of words. We have heard of AI, artificial intelligence. We have heard of machine learning. We have heard of deep learning sometimes. So we have heard about many things, especially if you are watching a lot of movies. You may have heard these words, especially you may have heard that artificial intelligence is going to destroy the mankind and going to attack the world. And a lot of discussions are going on. What's the future of AI? What is actually AI? What is machine learning? And where is machine learning standing at the moment? What's the difference between these three things? So I think Nadi's question is pretty good, pretty straightforward, and that's where we are going to enter this session. If you think carefully, gentlemen and ladies, of what's the difference between the artificial intelligence and the machine learning and deep learning, because deep learning is also getting a lot of traction for the moment. So if you think very carefully, what are the differences between these three things, there's a huge difference between these things. I would say the overarching one, the bigger one, the bigger umbrella is always the artificial intelligence. Now, artificial intelligence is always the bigger umbrella. I mean, it's the big one, and everything else is beneath artificial intelligence, and everything else is built beneath artificial intelligence. That's the beauty. And if you think carefully of the artificial intelligence, the main objective of artificial intelligence is to provide a set of algorithms and some information to solve some problem, which is kind of very intuitive and purely automatic to humans like me. Now, let's take an example. Let's see what you can see from your eyes at this moment. Think for a second what you can see in your environment. I'll tell what I can see in my environment. I can see a glass of water. I can see my mouse. I can see my mobile phone, and I can see my books here. I can see my light here. I can see another screen there. I can see a lot of things, and I can interpret all those things. And it happens automatically. I don't even have to think. All right, let me think at my glass of water. Here is a glass of water. I don't have to even think on that purposeful, because it has been here inside me for a very long time, and it automatically happens. It's so much intuitive. And this feature, this ability, if you can give that to a machine, that's the ultimate objective that you can think from an artificial intelligence perspective. And what you can then say as the objective of artificial intelligence is to give that ability for the machine to think and take action like we human beings do. And now the content of an image, understanding the content of an image is pretty something close to that. So you take an image and you understand, all right, here is the cup, here is the book, here's the pen, here's the pencil. That's understanding the content of the picture, which is intuitive, which is purely automatic, just like you and me do. Now you understand it's pretty complex, isn't it? I mean, even a little kid can do that. But to give that capability to a machine is a pretty hectic thing. And that's what's the objective of the artificial intelligence is. You can call it automatic machine reasoning, if you need a bit of, a typical technical jargon. And then you have the inside diagram inside artificial intelligence, which is called generally machine learning. And the objective of the machine learning is pretty, I would say, a shorter version or a smaller version of the artificial intelligence. And generally, the objective is to recognize patterns and to learn from the data. So if you are thinking of learning from data and also recognize patterns that are emerging from the data, that's generally where machine learning fits into the purpose. And then we have the deep learning, which is a much more deeper version. In fact, you may have already heard of some words like neural networks, which is a form of machine learning. Machine learning has multiple types of algorithms, multiple forms of classes, and neural networks, and especially artificial neural networks, is one class of machine learning. And one specific segment of artificial neural networks is called deep learning. It contains multiple deep levels of machine learning, which is a much more specialized version of machine learning, and that is what we generally call deep learning. So now this question is pretty straightforward, and it's pretty important question. We have three levels. We have the artificial intelligence, and inside that we have machine learning, and inside that we have the deep learning. And in this program, we are going to talk a bit more on the machine learning aspect, which is the secondary level. And if you are interested in going to the next level, maybe you are a student at the moment, maybe you are working at the moment, maybe you are at the university level, undergrad level. At any level of this your life, machine learning will be able to help you. It doesn't, you don't want to become a technically savvy person. It's a plus point always. You don't need to be a mathematically absolutely a genius from mathematics to learn and use machine learning, because it has become quite improved at the moment. It can be used, rather than you start researching, it can be used for fundamental activities, but it doesn't challenge you, or it doesn't stop you from taking research levels. So if you have research interest, this is a very lively area. You can go on that. Just to, out of curiosity, how many of you are students? How many of you are undergrads? How many of you are working people? If you are a student, type student. If you are a working person, type working. Or if you are undergrad, type undergrad. Let's see what your demography is. Brilliant. We have a lot of students, and students working, undergrad, brilliant. Students, we have a lot of students. Thank you very much. We have a lot of undergrads, and we have a lot of working people. Brilliant. So it's a good mix. It's a very good mix, and we love this audience, and we love you all. Thank you very much for this absolutely gorgeous interactivity. Let's keep this fun going on. Nadi, I believe I answered your question. So let's move
Yeah,
forward with this.
thank you, Tilna. If you look around, we can see AI in everywhere, right? Applicable in many areas such as image processing, medical diagnosis, banking, finance. Even we go to bank, we can see a lot of application using machine learning and artificial intelligence. How we can apply this to a application? How we this apply into a application? What are the application we can see in real world?
Super. That's kind of the beauty of learning machine learning. I mean, that's the reason I said you don't need to start from the very beginning. You don't need to implement the wheel. Instead, a lot of wheels are there. It's just a matter of putting everything together. You can create something new that can be, solving a real problem. So machine learning has evolved for a very long time, and it's now applicable in many, many, many different areas. It's already being used in different areas. You can, in fact, see a lot of applications which are using machine learning. Even without knowing, you may be using machine learning applications. I mean, think about this list. I'm going to show a list. Think about this list. If you look at this list, you can see multiple things which are already being used by you. Probably you know about that, probably you don't know. Let's take a very simple example like email spam. I mean, you know about email spam. You hate spams, don't you? Now, I hate spams. I go to my Gmail or I go to my office email, and if there are a lot of spams coming, it's a hectic to me. It's difficult for me. I mean, now the students, it can be, you can be undergraduate, you can be working. It's applicable for everyone. It's a difficult time if you are getting a lot of spams. So it the Google, the Gmail platform, and a lot of other email providers have now a spam filter type of a thing where they're using knowledge and previous data and a lot of features to understand whether an email is a spam or not. So even without knowing or with knowing, we are using machine learning every day. And that's the simplest thing. That's kind of the simplest thing. That's something that we are using every day. And you may have seen agents, personal agents. You can go to some websites and talk with some things which are actually purely artificial, not a human being. Bots are there. And we are talking about self-driving cars, which are fantastic, especially about Tesla. They are introducing self-driving cars, and near future we are going to see driverless cars, driverless vehicles. Even there are a lot of research going on driverless trains. So in near future, in very near future, probably we'll see some cities completely running without any drivers. And another thing that I have seen often is if you go online shopping, like let's say Amazon or eBay, when you try to buy something, generally these platforms are recommending you to buy something else. Probably they will say, all right, you bought this. Other people who bought the same thing bought these things also. So it's product recommendation engines. Their powerful product recommendation engines are suggesting you things that you might need for the next phase. They are giving book recommendations. They are giving product recommendations. They are talking about traffic predictions. Even when you want to go somewhere, now the first option is taking your phone and going to Google Maps or something like this and checking how the traffic looks like. Machine learning is doing all that magic there. And speech recognition is fantastic. When you're meeting virtually now, you can automatically generate captions. That's understanding my speech. And speech recognition is completely brilliantly working now. And image recognition, just like Nadi mentioned, has evolved a lot. Now it's evolved a lot that it is being practically used by a lot of people, a lot of organizations, a lot of companies, a lot of organizations, and a lot of people are now using this. And it is an active area. Even if you think of research, the research in the machine learning domain is pretty active. So if you are an undergraduate, if you are already working, and if you have interests in machine learning related postgraduate or research objectives, I would say that this is kind of a very active area. I have a lot of friends who are in other countries who are directly, lively integrating with a lot of labs, especially in the United States and a lot of other countries where they are lively working with a lot of machine learning related research. So I would say there are a lot of applications which are live, which are already there, which is active, as well as there's a research capability, because it's an evolving subject, because it's a live subject. Nadi, I hope I answered your question.
Thank you, Telina. I think our audience also having so many doubts in their heads. So don't be hesitate. You can add your all the question into chat box. I can ask from Telina. So Telina, machine learning is a programming computers to do things by looking at the past data. There are some learning modules, right? We call it unsupervised, supervised, and reinforced. What are they? How we can use in practical way?
Brilliant question. So we are going to go into a little bit deep, ladies and gentlemen. I hope you have your notebooks and your pens and pencils. You can basically capture screens, but the best way is for you to actually learn by actually taking down some notes. So let's dig a little bit down into the notes. But before going on that to that important question from Nadi, the objective of this program, as already mentioned by Nadi, is to go through the fundamentals covering the breadth of the technology. I understand this is a very deep subject, so we will not be going to the deep machine learning, Nadi, but we'll be covering the breadth of the thing. So gentlemen, ladies, at the end of this program, we will be able to not just learn, not just understand, but be able to run basic classification machine learning model. I mean, after today's 2 hour session, we will be able to run machine learning models, and we are going to give you almost all the tools, all the actively working environments. You will be able to test this right away, and you will be able to do some brilliant classification machine learning models right after this session. As well as we will be doing some advanced exercises where you'll be identifying some objects and some scenes, and we'll be doing this in a fantastic way. And what do you want to run this? What do you want to do? this program, what you need to attend, what are the things that you need. If you think carefully, well, the things are pretty evolved. So I won't say that you need a lot of technology here, but you need a very important thing. Listen to me carefully. Listen to me very carefully when I say this. You need one very important thing if you want to succeed in this program, as well as the other programs which are going to come in this way. In this series, we have a lot of programs. So this is the first thing. This is the one and only thing that you will need to become a next level person, to become so successful in this course. And that is nothing but an open mindset. An open mindset about learning. If you are open to learning, and if you are ready to get all these things into your head, and if you are open with your mindset, and if you are ready to learn things, you may sometimes you may have already heard of these things. You may be completely a novice. You may be completely a new person to this subject. You may be completely someone who has already grasped everything. And I'm pretty sure for almost all of you, despite of your knowledge, there is something from this course. That's why we ask you, that's why we invite you to have an open mindset about this course. So I believe we are good with that. And the other factor that I'm going to mention before diving into Nabi's question is the difference between prototyping and production. Now, I understand producing, or coming up with a production grade machine learning needs a lot of resources. You need huge machines to run inferences. You need a lot of software. You need a lot of external methods and algorithms and professional level software. But in this course, we are going to help you to come up with prototyping. At the end of this course, we need you to be brilliant in prototyping, so that when you go to the industry, when you go to the next level, production will become absolutely easy. So we are not going to go to the production level courses, but we'll be doing prototyping level courses. I think this is pretty clear. Our objectives are pretty clear to you. If we are all good with this, if we are all good with our objectives, if we are all good with the open mindset, type "I am ready" in the chat box, and let's dive into this machine learning fantastic subject. So type "I'm ready" if you're ready, and if you understand what we are good. Thank you very much. Thank you very much for your fantastic response. And if you are ready, let's kickstart this. Just to answer now this important question, machine learning has actually three folds. Machine learning is, in fact, can be considered into three aspects. It has three things that you need to know. It has basically three branches. What are these important three branches? There are called unsupervised learning. That's the first one. The second one is called supervised learning. And the third one is called reinforcement learning, reinforcement learning. These are three branches of machine learning. And these are brilliant things to learn. And it is not expected for you to know all these things at once. It doesn't happen that way, my friends. What generally happens is it's okay for you to have a fundamental idea of what these things are. And then what's going to happen is when you get a problem, you're going to evaluate what's the best thing, and then you're going to apply your knowledge. So it's not something like you learn everything and then you apply your knowledge. It doesn't happen that way. But you start from somewhere, then you get a problem, you find what's the best algorithm to put, and you put it. So let's identify what these three things are in a very high level, kind of a nutshell. And let's start with supervised learning. Supervised learning is mostly type of a prediction model. It's helping you to predict about the future. So if you want to solve a problem more like supervised, more like a futuristic or prediction about future, we are talking about supervised models. So if you think about the goal of supervised learning, you can look at the supervised learning model on the red color. It's more like about learning a model from labeled training data. So you already have some labeled data. You already have some training data set. So you already have some data which is already pre-programmed, pre-labeled by someone, by a human being or by another program. They are pre-labeled. So this is a set of labels. This is a set of labels which is already labeled by someone. Let's say I am the person who is programming. Here's my question. And in order to solve this question, I have a pre-set of data. And this set of data are already programmed, pre-programmed data, pre-labeled data by me or by another program. And this pre-labeled data will allow you to make predictions about unseen or future data. So you have the label data, you use that to train the model, and then you have a trained model, a supervised model, and that model can work with unseen data or future data. That is the beauty of supervised learning. So in supervised learning, we are talking about having previously labeled data and then talking about futuristic data, predicting about futuristic data, which we have not even seen. That's the beauty of supervised learning. And this is absolutely gorgeous. So we'll talk about supervised learning a bit more into the next sessions. And then we have something called the reinforcement learning. Now, reinforcement learning is brilliant. What you need to do there, it's the goal of reinforcement learning is brilliantly, generally, to develop a system that improves its performance. So you have your objective is to generate a system. Here's a system. You want to generate this system that will keep on improving its performance based on some experience that it gets. I'll give you an example. The best example I can think of is a game like playing chess. If you want to build a machine learning model to play chess, let's think about building a model to play chess, right? So what you need is a model, a solution, or a system that can play chess. But think of that. Playing chess has the ultimate objective, either to win or to lose. So you can build a model either to win or lose. That's your end objective, isn't it? You can either win or you can either lose. And you can imagine every move that you do, either your pawn moving from one square to the next square, or you taking the opponent queen, or you giving yourself, your pawn is giving yourself, all these moves are going to help you to either reach the winning goal or the defeating goal. So you are gaining experience as you are playing, and every move that you make is going to add experience to you, and it's going to add and improve your model. That's what reinforcement training is. And reinforcement is mostly available in game AI, if, as you can see on the slide. And there are a lot of other objectives, a lot of other applications of reinforcement learning also. And then you think of the fanciest way of machine learning, which is the third branch, and that is about unsupervised learning. Now, in supervised learning, you learned that we are going to provide you with some data which is already labeled. So we know about already labeled data. But in supervised learning, we don't have such kind of labeled data. We don't have such kind of already labeled data. Instead, what we have is a bunch of data. We don't know what this data is about. We don't know what this data contains. We don't know anything about the data. But we are seeing the possibility of whether we can capture or whether we can see some patterns from this data. Can we explore some structure in this data? Can we extract some meaningful data from this set of data which are not labeled? That is what we are talking about, unsupervised learning. These are fantastic things. So we have three things to talk about. We have the supervised learning, we have the reinforcement learning, and we have the unsupervised learning. So supervised is you have previously recorded labeled data. Unsupervised means you don't have previously labeled data, and reinforcement is making a system to achieve a goal where the system itself is learning from its experiences, mostly available in gaming. And before again moving into the next level, let me show you some very cool things, because at this course, at this first 2 hour session, we are going to more talk about the supervised learning. Because of that, I'm going to talk a little bit more on the supervised learning. When you go to supervised learning, it has basic two functions. The first one is called classification. The second one is called regression. Let's see what this classification and regression is, because these are generally the two things that you often hear when it comes to machine learning. These are the generally mostly available, mostly fundamental, mostly popular problems that generally gets in our way. In fact, I've been working in the industry for about 10 years now, and most of the questions, most of the business problems are around supervised learning most of the time. I'm not saying the other things doesn't come up, but most of the business problems, most of the applications of machine learning are generally from the supervised learning. So let's dive more into the supervised learning. And the first thing that comes into my mind is classification. Classification is pretty simple. You have a set of data, and you are trying to see whether you can classify between two things, whether you can easily make them into multiple groups. Can you put them into groups? Example, email, spam, as we talk. When you get an email, can you classify that email as a spam email or a not spam email? So it's pretty easy. If you look at this picture that you are seeing at the moment, plus means not spam, minus means it's a spam. So the moment you get an email, can you classify that email as a spam email or not spam email? That's a classification. Basically, we call them binary classification because binary means two. You have only two outputs. Either it is a spam or it is not a spam. So we have a binary classification. But in classification, it doesn't need to be only two. It can be even multiple methods of classification, multi-class classification. That's the technical term we call that. That's called multi-class classification. I want every one of you to type that term, multi-class classification. I want all of you to type that, multi-class classification. Type that, multi-class classification. So when you say classification, you are classifying data into multiple classes. In binary, you are talking about two classes, either it is spam or not spam. But when you say multi-class classification, you can have multiple classes. The best example that comes into my brain at the moment is handwritten character recognition. See, there's a famous question going on. Can you recognize handwritten letters? See, I don't know if the system can understand my handwritten letters. My handwritten letters are pretty bad. Nobody can understand. Even my wife can't read my handwritten things. If you have a bad handwriting, don't worry, you are with me. But there's a very good program, a lively program, and it's already almost kind of a solved problem how to detect handwritten questions, handwritten fonts, handwritten characters. And if you think of English alphabet, you can see that it's a multi-class classification problem because you have a known set of classes. If you think of alphabet, you have only 26 classes, 26 letters. Let's imagine only the capital letters. So you have only 26 opportunities, only 26 options, which means everything that you write should be one of 26 classes. So we are talking about classifying what you are writing into 26 multiple classes. That's why we call that a multi-class classification problem. So that is classification, and it doesn't need to be, again, it doesn't need to be just two classes, but it can be multiple classes. All right. And then we go to regression. Now I like regression because when you come to regression, that is not about putting them into multiple classes, but that's about predicting something linear. Now if you are much into undergrad level, you will understand this better. But if you are a student, you will still understand this better. Remember when we were in grade 9, we learned about graphs. Remember that y equals mx plus c, the linear equation that we draw in grade 9. I still can remember we draw that graph, y equals mx plus c type of a graph. This is something quite similar. Remember, in y equals mx plus c type of a equation, we could predict y when we know x. We could predict y when you know x. It's the exact same thing that we are trying to do here. What we are trying to do is, when you have set of data, you are trying to draw a line like y equals mx plus c. And when you can draw that type of a line, you can predict y when you know x. Let's take an example. Let's take an example, something like, um, can we predict your O-level mathematics results? O-level mathematics results, the marks that you are getting for O-level mathematics, is it possible for you to predict? If I ask you to predict O-level mathematics results for a student, you may tell me, well, I need a lot of data from him. How many hours did he sleep? How many hours did he work? How many days did he attend school? How many hours did he actually solve problems? Likewise, there are a lot of data points that you need. But just out of curiosity, shall we make it much more simplified? Shall we say x is the time spent in studying? So x means the horizontal line. Horizontal line is time spent on studying. That's your x. And then y will be your mathematics score. So you have mathematics score, which is the y-axis. Then x-axis is the time spent on studying. Now, if you get a lot of data, let's say you talk to 10,000 students, and I understand what's their time spent for their mathematics stream, and then you get their answers. So this is supervised learning, because you have already a set of data, already you have a set of labeled data, and you are trying to draw that, and then you are going to understand the regression model. You're going to understand the y equals mx plus c type of the curve. And when you know that curve, it's pretty easy for you, because the moment you know the number of hours you have spent for learning, you can always predict the mark. So this can be, varying from here and there, but that's a typical example. So the moment you know that it is something that can be predicted using the data, we use regression model. And we are talking about linear regression. We can see a lot of questions coming up. Thank you very much for the questions. Now, there are some other words like linear regression. And when you say linear regression, it is exactly what we are talking about. We have a linear model. Linear means a line. A line means something like y equals mx plus c type of a line. So linear regression. If it is a linear regression, can it be linear? The graph needs to be linear. Because of that, we can easily predict. When you know x, you can guaranteedly predict what's going to be y. So it's absolutely going to be fantastic. That's a nice question. Somebody asked, can it be the other way around, like learning hours in x-axis? Yes, absolutely yes. X-axis can be your independent variables where you can control. So your learning hours can be your x-axis. Your time spent for your mathematics stream can be your x-axis. So anything that you think is independent can be your x-axis. Just for the moment, I have considered only one variable, remember? Only one variable. And there can be multiple variables for your x-axis. Remember that. So there can be multiple variables, which we generally call multivariate linear regression. It's a bit beyond this course. So I'm pretty sure you can learn about these things. It's called multivariate linear regression. For the moment, my graph shows only one variable. So this is just single variable linear regression. Thank you very much for the fantastic questions that are popping up. And so we have talked about supervised learning, one type of supervised learning, which is classification, and the other type of supervised learning, which is regression. So fantastic. Nadi, I hope I answered your question. I know it took a little bit, but I hope I answered the question. I see a lot of questions also popping up from the audience.
Yeah, we are having some questions here.
Brilliant. We'll
Um,
come back to the questions probably, Nadi, because I see we are spending a lot of time and there are a lot of people. So is it
yes,
okay if we move to the questions at the end, probably?
yes, that's better, I guess.
Thank you. All right. Right. So pretty sure that some of you are still novice to the industry. Some of you are still new to this course, to machine learning. Probably you may want to clarify some of the words that we generally use. I mean, the best thing is some of the machine learning people, they tend to use a lot of jargon when they are talking. They want to use a lot of technical words, so that it will be difficult for the audience member to listen and understand what they're talking about. It's pretty bad, to be honest. I mean, if you really know what you're talking about, they won't generally use jargon. But it's better to know jargon. It's very important that you know some important words in machine learning. So let's go into one step further and try to learn some of the very important some words, some jargon, some terminology that are generally used in machine learning domain. I'm using a very important or very popular data set in machine learning domain, and it tells about certain set of flowers. We'll come back to this flower data set in a while, but I want to talk about some of the words, some of the famously used features, or some of the famously used terminology, some important words that you should know. Here are some important words. What is a sample? Now, this is a table. You can see the table. And this table is a set of features that are extracted from certain flowers. On the right-hand side, you can see flowers. These are some type of flowers. There are three type of these kind of flowers, which is called setosa, and there's something called versicolor, and there's another one called virginica. So these are three types of flowers, 3 families of flowers in this family, in these flowers. And then somebody has collected a data set of 150 flowers. 150 flowers. They have collected a data about these type of flowers. When I say flowers, there are 3 families of these flowers. The first family is called Setosa, the second family is called versicolor, and the third family is called Virginica, as I have mentioned in the table. And there are 150 flowers that they have studied. And on each flower, they have captured 4 information. First one is called the petal length, the length of the petal, and the width of the petal, and the length of the sepal, and the width of the sepal. So 4 information about each flower. Likewise, there are 150 rows, 150 flowers, and for each flower, there are 4 different features. So what are these things? Each row in this type of a data set, you can call it a sample. You can call it an instance, or you can call it an observation, right? So we know now what is a sample. And then you have this famous word called features. What are features? Now it's pretty simple when you have this table, because all columns, see, you have 4 columns here. You have 4 things that you have extracted from the flower. You have the sepal width, sepal length, and the petal length and petal width. These are the features that you have extracted from the flowers. So when you have this set of data, all the features are the columns. So now here, these are the attributes, these are the measurements, these are the dimensions, and these are the columns. So if you think of this example, this data set, you have 150 samples where you have 4 features for each sample. And then you have class label. Each row has a label to that. What type of a flower is this? Is it a virginica flower? Is it a versicolor flower? Or is it a setosa type of a flower? It has a label. These are some fundamental words that you generally should know when you are talking about class labels, features, samples. And apart from that, we have another important set of words that generally you get bogged with when you're talking with someone. Example, like training example. You talk about training. Training is pretty important. Training is you create a model, a machine learning model. So you have a system that can predict, a system that can automatically take some decisions, which is a model. That's called a model. And when you get that model, the way of fitting things into this model, or making sure that this model is reinforced to take certain decisions automatically, it's called training. So you have a model and you're training that, you are making that better and better and better. Then you have a training model, and you have a model, which is a system that can take automatic decisions. And then you are making that model better and better and better. And it's called model fitting, or it's called training. So what's a training example? Training example is just one row in that particular dataset table that I showed you earlier. So when you want to train something, what you do is you get the data set, extract each row, and feed the model with that data. That's called a training example. And you feed that data into the model, and that's called training. That's it. And features, we now know, you take that table and each column is a feature, and the target itself is the label. What's your output that you want to get out of from this? And then there's something called the loss function. Loss function. The loss function is a method for you to find how well your algorithm is actually performing. Now, I mean, we talked about that chess program, remember? Reinforcement algorithm, playing chess. How can you find whether your algorithm is better than another algorithm? How do you find that? How do you find that your algorithm is becoming better? How do you find that the algorithm is becoming better and better and better, and it's growing? Loss function is going to help you to do that. If the loss is more, if the error is more, if the loss is more, it's a sign that your algorithm is not better. It's not it has not come to a expected level. So you have to deal with the loss function and minimize the loss function. You have to minimize the errors so that the algorithm or this model keeps on bettering themselves. And that's a loss function. Now, just out of your curiosity, let me tell you something. Don't even think of learning all these things at once. This is not something that you should in my personal view, that you should, this is something that you should in fact have fun. I mean, don't get bogged down with all these words, all these letters, all these rows, all this jargon. This is not a subject that you should go down because of these difficult jargons or mathematics. That's not the objective. The objective is to have fun. So if you want to have fun, don't worry about this type of jargon, because the jargon, you will get it. So let's deep dive and let's try to understand some of the use cases. And let's try to understand some of the ways that we can actually apply these things and go on to these things. So we have now heard some of the words that are typically used in the machine learning domain. And now, even if you are new to machine learning, you will be able to talk about some people about machine learning. Even you will be able to use this knowledge for machine learning, right? And now we are really geared to start some of the cool stuffs in machine learning. And that's a very good question. What are from Harsha Nadi? I think this is kind of a important question. So before I forgetting, is it okay if I go to this question, which is related to the research areas in undergraduate?
Yes, yes.
Brilliant, thank you. I
Uh,
think Nadi
one,
is also coming from the academic background. Yes, Nadi.
one student, should I have to say that question?
Yeah, please, please. I think it
Uh,
is not visible
One
to others.
student asked him from us, what are the good research areas for undergraduate students in machine learning domain?
Brilliant. Thank you, Nadi. Even Nadi can answer that question because Nadi is coming from a lot of academic background. We have seen a lot of options, and Nadi can probably add after me. So I think it's Harsha who asked. So Harsha, it's a very important question. Thank you very much. There are a lot of good research areas when it comes to machine learning domain. Let me tell you some work that we are doing at our company at the moment. So we are at the moment working with a lot of image comparison, a lot of fraud detection, a lot of cybersecurity stuff. When you go to online, let's say online payments, fraudsters are trying to fraud you a lot, and cybersecurity is becoming a lot of important aspect. And we are trying to see if you can apply machine learning and artificial intelligence into the area of online security, cybersecurity. And this is a vastly improving subject. Harsha and also other members, especially cybersecurity is getting a lot of attention, and AI and machine learning is coming into that area, especially into authentication field. So that is one thing, which is with video analytics and audio analytics sometimes. And another thing that you can go on and learn on your own is called deepfake. This is another research area which is going on at the moment. Deepfake is how people are generating artificial videos about people. I mean, if you go to YouTube and search deepfake, you will see that there are artificially created videos about people. I mean, they are not actual videos, but artificially created videos. You may see artificially created videos of Obama giving speeches. These are completely artificial, which are absolutely like real. So these are coming up, upcoming research areas. There's a fight against whether can you work against artificially created videos. Can you create and can you understand these kind of things? These are in the authentication domain. But apart from authentication domain, there are a lot of work happening in the machine learning domain, image processing domain, especially like driverless cars, driverless trains. How do you find and interpret the environment using image processing and apply the machine learning on top of that? And how do you use driverless cars? So there are huge, this is completely huge, and you can definitely go into research areas using this. And just to add on that, we are at the moment working on robotics. Robotics is pretty brilliant in machine learning. It's filled with machine learning. Nadi, may I ask you, are you currently working with any machine learning type of research?
Actually, I have done one machine learning application
Right,
recently. So it's basically I have given one a solution for real world example.
brilliant.
So it's kind of should I explain about the application?
We'll probably go very quickly.
Yes, it's kind of an application that we have. That double economy center. We have given that solution to that application. Um there are so many wastage happening because of excess of food
Right.
because they don't have a probably good idea how to manage their foods and those kind of how they can cultivate those foods and all. Because of that
Absolutely.
reason, waste in food is highly happening in these kind of centers. Because of that reason,
Brilliant.
we target what kind of cultivation methodology they can give, uh, we can give them, and what kind of harvesting uh, measurements we can give them. So there are
Superb.
the things uh, we got like measurements to give them.
Thank you. Thank you, Nadi. I think, Nadi, that was brilliant. It's a good eyesight and opening for our students and our people who are, attendees who are here. Just to note on Nadi's point, what you generally get is, just to enlighten you, what you generally get is a business problem. You get a business problem. Here's a business problem, and they're going to ask you, all right, here's a business problem, solve it. They're not going to tell you that this is a structured way of solving this. They're not going to tell you whether this is supervised learning, whether this is unsupervised learning, or this is reinforced learning. Nobody knows that. What they already know is there's a problem. That's it. They don't even know whether this is a problem for machine learning. They don't know whether this is deep learning or this is artificial intelligence or what. They have a problem. And it's your responsibility as a technical person who is a brilliant expert in machine learning, what type of thing to solve. Now, it doesn't say that all problems in the world needs machine learning. Some people think that. Some people think that all problems can be solved with machine learning. No, it's not. Sometimes machine learning is not that I'd say improved enough to solve some of the problems. Some of the problems are not yet solvable, and it's improving day by day. That's why we call it's a live field. So don't think that every problem has a solution in machine learning. No, but a problem can be approached with machine learning, and it's your expertise that will help you to see if this problem needs a supervised learning model, unsupervised learning model, or a reinforcement model. So with your expertise, as you are starting this, you will grow and you will learn this best. And we are inviting you to start from somewhere. If you have not yet started, probably supervised learning is a best place for you to start. So now we have learned some of the key terminology, and because of that, let's move into a very important section, what we generally call the roadmap of machine learning. Now, this is a roadmap, a generic, very generic roadmap for machine learning. And this is applicable for any type of machine learning. So it's brilliant. I like this model because this is kind of the summary of the entire machine learning domain. If you think of that very carefully, about machine learning and how machine learning roadmap works, this is how it works. And if you think of that, the first section, which is data coming in, you have raw data coming in, like supervised, like either it can be labeled data or unlabeled data, but they are raw data. They are not processed, they are not done anything. So you have raw data coming in, and generally you need to approach that data and you need to process that data. Before even applying machine learning algorithms, you have to talk about that data. You have to purify that data. You have to pre-process that data. You have to make that data ready for your machine learning algorithms. You have to pre-prepare that data. And sometimes pre-preparation of that data can take a lot of time. Believe me when I say that. Even capturing data is going to take a lot of time sometimes. Collecting data is going to take a lot of time. You take a lot of data and then you pre-process data for a long time. So if you think of a typical machine learning approach, it's not just writing code from the day one. Sometimes you have to collect data, see if these all data are meaningful, and you have to clear those data, and that has a lot of work to do. That has a lot of weight for that. So pre-processing is the first stage, and it's an important aspect. You have to do a lot of pre-processing to the data, and pre-processing raw data rarely comes in a ready way. I mean, rarely the data comes in a level that is directly applicable. It doesn't generally happen. Because of that, you have to remove a lot of unnecessary data. A lot of features should be removed. For example, think about that picture of that flowers that I showed you, these pictures. Remember this. Imagine you have 150 images of these flowers. You may have a lot of features from this, isn't it? You may have the colors of the pictures, hue, saturation of the pictures, lot of petal lengths, lot of widths, lot of heights, lot of intensities, lot of data about the flowers. and most of the data will not be even applicable to your problem. So the first thing to do is to purify this data. And this data set that you are seeing here, the table, is itself the purified data. This is the only data that we need to solve the problem. And coming to this level is the first problem. That's called pre-processing stage. Okay, that's called the pre-processing stage. So pre-processing stage, after the pre-processing stage, we have a very clear set of data. Very clear set of data. You can see at the pre-processing stage, you can see that there is a curve, and it's an iterative process. It doesn't happen just once. You have to iterate through that. You have to go to that again and again and again and again. Sometimes you have to go front, come back again, purify that again. This is the life of machine learning, and it's fun. It's almost fun. And then when you have a set of purified data, a ready set of data, then you go and apply your machine learning algorithms. Now, the fun thing here that I learned by the hard way is that there is no such thing called one algorithm that will fit for all the problems. There's nothing like that. I thought machine learning was like this. There's nothing called fit for everything. No algorithm, something like this. No algorithm, no program, no model fits for everything. Every problem is different. Every problem is unique. Let's say you have a model which is good for classification of flowers. Now, even if that classification of flowers model is good for this problem, for another set of flowers, it won't work. Sometimes it won't work. Because of that, if you have another set of flowers, maybe you have to come up with another algorithm for that. So algorithms, when you say algorithms, the models, those are typically unique to problems. There's nothing called fit for everything type of a model. Seldom there. It doesn't exist. Most of the time it doesn't exist. So most of the algorithms are not fit for the entire purpose, but it only fits for the purpose. Every question is unique. Every problem is unique. Because of that, you have the third aspect, which is applying learning algorithm to that data. And after applying, you have a candidate model and you have to test that model. You can see there's iteration here. That iteration is iterating to find the best model. So you apply one model, check if that goes, if it works, is the accuracy level good? Is it going good? Is the loss function better? Or is it improving? If it is not, go back, apply the next model, see if it is working. If it is not, go back, apply it again. You iterate through that process again and again and again and again until you find a better version, until you find the best version to solve that issue. And then after you find the best of the best model, the best of the best algorithm, brilliant, then you have the chosen model. Then you have finalized your model. Brilliant. Now you have a chosen model. It's all about using that chosen model to predict and using that for the application, which means the next level, the production grade machine learning comes only after this. So this is basically the prototyping roadmap. You have the prototyping. For the prototyping, there are three aspects then. You have the pre-processing stage, there is applying the learning model stage, and then coming up with the results, the final stage. And this is kind of the typical stages in the machine learning domain. We'll take an example and see. We'll imagine for the moment that you already have pre-processed data. Let's take an example. And let's say that you are talking about a particular problem. Let's say solving the handwritten recognition problem. Let's say you have a set of handwritten texts and you need a model to predict these handwritten texts. And let's say you are supposed to detect what's the best model to do this. Let's say you have three models, model A, model B, and model C. Here are some results that you obtain from this model. So the first model, model A. Model A is 95% accurate for European handwritten letters, which means people who are in Europe, when they write, this model can detect up to 95% of accuracy. Okay, up to 95% of accuracy. By the way, I forgot to tell you the problem. The problem is this. The problem is to detect handwritten recognized letters of Sri Lankan people. Okay, Sri Lankan handwritten recognition model. This is what we want. So the model 1 or model A. Model A's answers are this. It's 95% accurate, but only for the handwrittens which are in European type handwriting. So all the data sets that we have are from Europe. The members who have written are from Europe. These are European handwritings, but still English, but these are European people who have written. And the accuracy is 95%. That's number one. And model 2, model B, is 87% accuracy, but it comes with a very large scattered letters data set, which means there are letters written by a lot of people, scattered set of data from all over the world. There are large set of data coming from all over the world. And model B works for that scattered data set, but it's pretty low, 87% accurate. All right, let's see whether that works. But then we have another option, which is model C, and it is 70% accurate, which is again for very large scattered data set. I mean, think about that large scattered data set to that international data set. For that international data set, the model C works 70%. Now here's a question for you, for every one of you. Are you, if you are the machine learning engineer here, right? If you are the machine learning engineer here, what's the model that you're going to use for your machine learning model? Is it model A, model B, or model C? Type your answer in your chat box, and let's see what is your answer. Are you going to use model B, model C, or model A? Okay, most of you are saying that you're going to use model B. Brilliant. All right, we have a fantastic set of futuristic machine learning individuals who are having fun and who are answering just like brilliantly. Absolutely, I love this audience. You are so interactive and you're so with us. Thank you very much for this interactivity. Brilliant. Almost all of you, 100% of you are using machine learning model B. Okay, nice. But still it doesn't guarantee that you will get brilliant outputs, because this is the reason. Let's think about model C. Model C says that it has only 70% accuracy for very large scattered data, which means 70% accuracy, which means when you get 10 people, there's a chance that 3 people will go wrong, right? Here's a good answer that I was expecting. Cobalt, his name is Cobalt. Let's come to that answer next. There's a 70% accuracy, which means when you try with 10 people, 3 will fail. 70% accuracy means that when you try with 10 people in Sri Lanka, there's a chance that it will fail 3 times, because we have tested this with international data. Remember, international data shows that there's a chance that it will work only with 7 people when you take 10 people. But still we are not sure, because we have not we have not yet tested this with Sri Lankan models, Sri Lankan test data, but we have tested this with international test data, right? The next level, what about model A? I mean, it has all the 95% accuracy. Why didn't you choose that? Why didn't you choose that? That's 95% accuracy, which means it's far better in accuracy. In terms of accuracy, it's the best one. It is 95% accurate. Why didn't you choose that? All right, maybe you have thought, it is only for European handwritten. We are talking about Sri Lankan handwritten. Maybe that's why you didn't choose that. Okay. Then most of you went for the middle ground, model B, because it's far better in accuracy, 87% accurate. And it is, not only for Europe, but it's pretty scared. Based on that level of detail, you took the decision that you are going for model B. It's a good decision just to start, but ladies and gentlemen, I'm going to tell you, probably the answer would not be that much straightforward, because to take that decision, you need a lot of data. You need data from Sri Lankan samples to check against all these 3 models need to be rechecked with our roadmap. Remember our roadmap? Our roadmap says this. Our roadmap is, when you have the data, you have to apply the algorithm to that data, not to the other data. You have to get Sri Lankan data, apply the model to the Sri Lankan data, and check if it is working for the Sri Lankan database. Although model A is working 95% for European data, are you sure that it will work for Sri Lankan data? Probably it will not work for Sri Lankan data. And the next one, model B, although it is 87% for world data, are you sure that it's going to work for Sri Lankan data? Maybe it is less accurate for Sri Lankan data. Probably model C, although it is 70% accurate for scattered data, probably it is more designed for Sri Lankan letters. And probably it will be the best thing for best thing for Sri Lankan case. So don't jump into conclusions, ladies and gentlemen. This is pretty tricky. I mean, it's very crucial to take this kind of decisions. As some of you are saying, A is bit biased. Yes, I understand. I mean, the fundamental thing that you want to learn here is that even I came into those kind of quick decisions that model B is the best, but you can't jump into that kind of conclusions that easily because of this roadmap. So remember, when you become a machine learning technical expert, this is your golden rule. The golden rule is your roadmap. The roadmap is everything. If you are still with me, if you are still having fun, type roadmap is important. Type roadmap is important on the chat box. If you are still having fun, and if you are still with me, if you are still having fun in these lectures, and if you are learning a lot, type roadmap is important. Roadmap is pretty important if you are into machine learning domain, because it's going to help you when you are going to become an expert in machine learning. Thank you very much for your interactivity, and I love you all for this brilliant interactivity, and thank you very much for this brilliant learning. See, I think we are proving something. The moment you are having a lot of fun, you are learning a lot, and I'm pretty sure that you are taking down a lot of notes, because these notes are going to anyway help you to learn more, to cover more breadth, to go and learn a lot of depth about this. And don't forget to have a little bit of sip with your water. Water helps you to learn a lot. And when you are learning, I mean, this is about the other type of learning. If you are learning, make sure that you are drinking a lot of water, because your brain works very well when you are brilliantly energized with water. Remember, water is important. Thank you everyone for staying with us and energetically answering all of these things. With that, we are going to now move a kind of a deviation from what we have been talking. We have been talking too general for the moment, and now we are going to directly deep down into a let's say much focused area, much more focused area, and that is something that we all have heard, which is called neural network. Neural network is something that we have all heard, but probably we have not yet understood what's a neural network. Let me here ask a question from all of you. How many of you have heard the term neural network? If you have heard the term neural network, type I. Type I. If you have heard the term neural network, if you have heard the term neural network, type I. Brilliant. Oh, goodness. Thank you very much. Most of you have heard the term neural network. And if you can remember, we have even learned about neural networks. We started to learn about neural network and neurons when we were doing our O levels. I remember we talked about neurons in our O levels. I'm not sure if the syllabuses are changed, but I'm pretty sure the neurons are still taught at the ordinary level. And probably you may have already seen neurons. So this is a neuron, because machine learning was inspired by the ability to think of human beings, the ability of human beings to think. Machine learning is inspired by that, because we learned at the beginning, artificial intelligence and machine learning is trying to give the ability for the machines to do things just like human beings. We are doing things automatically, intuitively, and can we give the same function to the machines? That's the objective. In order to do that, biologists, the scientists, found models of how we think, and they come up with a concept of a simplified brain cell, which is called a neuron. That's where everything starts. A simplified model of a brain cell. That's how everything starts, and that is called a neuron. And here is a simplified brain cell, or what we call a neuron. And we know about neurons. Neurons have multiple things. It has something called dendrite, which is the opening side, and then we have the axon, right? We have the axon, and at the end we have the terminals, which we call the terminal buttons. So we have the dendrites, and at the end you have the axon, and at the end you have the terminal. So these are the three more important things. And the fun in these neurons are interconnected in our brain. We have millions and millions of neurons in our brain, and it is growing since the day you are born, that I am born. I mean, I'm thinking from my little daughter's perspective. I can see how she's learning. I have a little daughter, a little kid, and she's learning so fast. She was not able to talk a lot, but now she's talking a lot by understanding the words that we are saying. She's listening a lot. And now she can pick the colors, looking at the things from the cartoon. She has learned a lot. She can look at certain things and pick, because her neurons are now improving and making a lot of connections, a lot of interconnections are happening. Because of that, we are becoming wiser again and again. Because of that, we can learn. So our learning comes from our ancestry, from our DNA, and from our learning from the data. Basically, it's kind of supervised learning, you can say. So you have a lot of neurons in our brain, and there are multiple signals arriving at the dendrite set. So we have the opening side. Here are some inputs coming into the neuron. And what generally happens is this. A typical neuron is just like a binary classification model, right? It's just like a binary classification model. What happens in a neuron is, when multiple signals arrive at a neuron, the signals will come into the neuron. Signals, what I mean by signals is, it can be a electrical signal or it can be a chemical signal, right? There can be hormones or there can be electrical pulses, voltages coming from one end to the other end. That's how we communicate. You know that we are sending information to the system using hormones, or it can be electrical signal. Basically, it's the electrical signal coming from one end to the other end. That's the input signal. So when the input signal come into the neuron is going to take a decision. If the accumulated signal, it's going to check if the accumulated input signal is above or less than a certain threshold. Here's that decision. Here's that decision. So there were some input signals coming in, and then the neuron will take a decision. Is this accumulated signal above a certain threshold, or is it below a certain threshold? If it is below a certain threshold, the neuron takes a decision that I am not going to fire the other neurons. No, the signal stops here. That's it. That's the finish. But if the input signal is above a certain threshold, it will fire the other set of neurons. So here's the input signal coming, and I'm seeing, is this signal above the threshold? No, that's it. Here's another signal coming. All right, here are some signals coming. Is this set of inputs greater than my threshold? Yes. Okay. Fire the other neurons, fire the other neurons, fire the other neurons. That's how it works. You have one neuron taking decisions. If it is above a certain threshold, fire the other neurons. If it is below a certain threshold, you don't fire the other neurons. Finish. That's the starting point of the machine learning that we are talking about right now, or even what we generally talk as neural networks. It all starts from this. Basically, what we are talking about is a model which are interconnected. A basic neuron can take this decision. This is the basic fundamental of a neuron. And if you just learned about neural networks, and if you think that you learned and understood how neural networks works, I mean, at least how a general neural network or how a neuron works, I think you learn now that it is kind of a binary classification model. It either fires or not fires. That's kind of the basic, most simplified version of a brain cell, a binary classification model. So a neuron is capable of taking a decision whether an input signal should be transmitted through the axon to the other neurons or not. So in turns, we can say a neuron is basically kind of a binary classification model. Everything is started with this. Everything is started with this. Neural networks is inspired by this. So if this is kind of if you understood how this works, I want you to type something. I want you to type NN, saying neural network, NN on the chat box, just to see if you understand how a neuron works. Thank you very much. Thank you very much for the interactions. Now you know how a neuron works. And a neural network is nothing but a collection of neurons interconnected to each and everything. So here's a neuron, you connect multiple neurons to this, and for each thing you connect multiple neurons. That's how you find a neural network. So now you know what a neural network is in a very fundamental level. Now I told you at the very beginning, we are going to cover about the breadth of the subject, And you can always go to the depth of the subject. There are a lot of books, a lot of courses, a lot of available research areas, a lot of research papers about these subjects, and you can always go and read and understand more about these things. So that's a fundamental important thing about machine learning, because it's a live subject, right? Let's take some cool example and let's try to formally define this a little bit. Now, if you are already in the undergraduate level doing having a little bit of mathematics background, you will be able to understand this bit more easily. But if you are not having a mathematics background, or if you are still not an undergraduate, or if you are not still if you are still a student, and if you can't understand what the mathematics that I'm going to show you, that's okay, because we are not going to learn about complex mathematic formulas. This is not about that. This is all about applying machine learning and doing something relevantly to solve some problems. So even if you find that to understand these mathematics is a bit difficult, that's okay. Forget about it, because you always have time to learn about these things. But let me show you that having a little bit of mathematical background always helps you to grasp some of the things. Let me give you some example. Let's take an example of running a mathematically based model. Uh, let's say something like a facial recognition, right? I like always facial recognition. So let's say facial recognition. Here's the face of a person. Right? Here's a face of a person. And you can see now, since we know what are called features, now you know when you say a face of a person is a collection of lot of features. A lot of features. What are features? Now you know lot of features are there, like the length of the eye, width of the forehead, length of the forehead, the nose position, the width of the nose, lips, ears, cheeks, cheekbones, and whether you have a mustache or not, the color of the eyes. These are all features, and there are thousands and thousands of features in a typical face. Thousands and thousands of features in a typical face. Let's take a real world example. Let's say a real world use case that we human beings typically do very good. How do we classify a girl from a boy? Let's take that fun example. You get a face, and I mean, you and me, we can definitely say whether this is a girl or boy by just looking at the face. Can we do the same ability? Can we give the same ability to a machine? Can we give the same capability to a computer? Just by giving a picture, can a computer say whether this is a girl or a boy? Let's take that example. I hope you understood the question. So the question is, you have a picture, can you say whether this is a girl or a boy? Now, I know you can say that, because you and me, we are human beings. We have seen this for a very long time, and our neurons are capable of doing that, because we have seen that for a long time, again and again and again and again and again. So our systems are already programmed to do that. Our systems are brilliantly doing that. But let's see how to do that functionality through the brain. So here are a lot of features from the face, right? From the face. Now, each feature is denoted by a letter X. A letter X stands for a feature. So X1 is a feature, X2 is another feature, X3 is another feature. It can go up to XM. M can be any number. It can be, let's say, 1,000. It can be 10,000. It can be 500, any number. Don't worry about M, but it's just a number. So X is a feature. It can be the color of the eyes. It can be whether you have the mustache or not. It can be the length of the eyes. It can be the width of the eyes. It can be the eyebrow color. It can be the width of the forehead. It can be the shape of the ears. Likewise, there can be multiple X's, multiple features. So X is a feature. W is a weight. Now, for example, when you have a picture of a person, do you think the shape of the eyes are very important, or the color of the eye, or the shape of the eye, the height and width of the eye is very important to consider whether this is a girl or a boy? I don't know whether this is true or false, but I think when you see a girl or a boy, the shape of the eyes are pretty important, because boys have some different eye shapes, and girls have some different eye shapes. I'm just saying, I'm not saying this as facts. Let's consider that it is the way. So let's say eyes are very important feature, which means eyes are very important. If you say something is very important, you give them a lot of weight. In order to say these are very important, you give them a high weight. W is that weight. So weight means those are important or not important. So if you find something is very important, you give them a big weight. W is the weight that you give to that particular feature. If the W is high, you are saying that weight of that feature is very high. Let's say another thing, something like uh, nose, the shape of the nose. Let's imagine it's not important for you to guess whether this is a boy or a girl. The shape of the nose is not important. Let's say it's less important. So if it is less important, the weight that you give is also less. So for the feature nose, you're giving a less importance, less weight. I believe you understand. So we have some features which are high weight. We have some features which are low weight. So some features, you have high W. You have some features which are with low W. That is high weight things, low weight things. So you have different features with different weights. That is, this is the mathematical way of representing a typical neuron that we are talking about. So remember, we are talking about a neurons still, right? We talk that a typical neuron can have multiple inputs, and each X is kind of a multiple input. So you can call this a net input. Z is an equation, and Z is always called net input because it's the collection of all the inputs. You can see W1, X1 is added with the next one, is added with the next one, is added with the next one, is added. When multiple things are added together, it's called a net, an addition. And what are the addition? It's the addition of weights multiplied by the feature. Weights multiplied by the feature. And when you add all those sort of things together, you have the net input. And there's a special way how you can represent these things mathematically, and it is this. You call it vectors. All W's can be put together in a mathematical form. You call them the weight vector. W, when you write in this way, it's called a weight vector. Now again, if you are a student and if you don't know what are vectors, forget about it. It's not important to go start learning machine learning, but it is a plus point. The more you know about these things, it's easier for you to learn. And vectors you are going to learn when you are talking about mathematics. And if you are undergraduate, I'm pretty sure you have already learned about vectors. So W is the weight vector. It's nothing but all the weights. Pretty simple. And X vector, now you can imagine, it's nothing but all the features. Pretty simple. It's a mathematical form of showing or illustrating all the points together. So when you list down all the vectors, when you list down all the weights, we call that weight vector, or W. And when you list down all the features, we call that the feature vector. So you have feature vectors and you have weight vectors. Brilliant. Now we have the vectors defined. Now what? Now is the time to do what neurons can do best. Remember, neurons can do binary classification. It can do two things. It can take a decision if the inputs or the net input is bigger than a certain threshold, it will send. If it is less than a threshold, it will not send. Remember, two answers, and that is called a decision function. Now, again, don't worry about the mathematical representation of a decision function, but the decision function itself is doing that. Pretty simple. I mean, even if you are a kid, you can learn this. A decision function is pretty simple. If a certain input is bigger than a certain threshold, it will be sending the information. Otherwise, it will be not sending the information. Binary, two things, right? So here, what we are saying is, in the model, you can see that we have 1 here and -1 here. 1 means fire the other neurons. -1 means don't fire the other neurons. 1 means turn on. -1 means don't turn on. Binary. And in front of them, you say, if Z is greater than theta. Theta is a mathematical representation of the threshold. Z means, you know now what Z is. Z is a net input. So we are essentially seeing or showing you how the neurons work. So if Z, if the set of Z or the net input is greater than a certain threshold, you can say for sure, all right, this is grade 1, or this is class 1, this is a male, this is a boy. Otherwise, you are saying this is a girl. That is how you classify things either as a boy or a girl, right? If the features or if the net input is greater than a certain threshold, you understand that as class 1. Otherwise, it will be class 2. So you can, the moment you have a picture, you can classify them as a boy or a girl, as a woman or a man, basically binary classification. This is how we take decisions in our brain. This is how our neurons are getting fired and taking decisions. I hope you understood. Now, if you understood how we have been doing so far, just type yes into the chat box just to give me an understanding that you are with me. So if you are with me, and if you just understood how a neuron works in a more mathematical work, more mathematical function, more mathematical way, type yes. Brilliant. Thank you very much for that fantastic response. Brilliant. So we have learned now how to more formally define a kind of a neuron. And then the rest of the things are pretty connected to this. Then we talk about neural network. Neural network. So we have a set of neurons connected to each other. Let's talk about neural network. What we then have is those set of same features. See, these are features, and each feature will be working with weights. See, we are talking about the most fundamental way how a neural network will be working, or basically how a neuron works. So you have one neuron where you have multiple inputs, and each input will have weights. Each input will have weights, and these weights will be connected together to get a weighted sum, which we called Z at the moment. Remember the previous one, we called it the net input, and this is the sigma. The sigma means it's the net input. So we have all the things connected. You have x1 multiplied by w1, you have x2 multiplied by w2, x3 multiplied by w3, and all these sort of things put together, connect together, you have the weighted sum. And then, most importantly, this weighted sum will be tested against something called threshold function. Tested against a threshold function. Remember the previous one? In previous one, we told if the weighted sum, if the net input is greater than your threshold, you take one. If it is less than a threshold, you take the other decision. And this threshold function can be denominated or can be denoted by different mathematical forms. Here I have shown you something called a step function. Step function. And step function is one way of showing a threshold. There are multiple other forms how you can take this decision. But the most fundamental way how a neuron works is based on a step function. Step function means it has only two levels. And the decision making is pretty straightforward because it is just like a step. You know how a step works, right? You know how a step works. In a step, you are either the bottom level or you are on the top level. You are either on the bottom level or you are on the top level. And the change is always vertical like this. You are either here or you are either here. And the change is always vertical. That's a step function. But it doesn't need to be a step function always. But this is how a basic neuron works. But think about these things. Look at these diagrams. These diagrams are different methods or different things how a step function works. There can be multiple step functions. Now, don't worry about these names. Don't worry about these things, because I'll tell you why you don't need to worry about these things later. But look at some of these names. You have step functions, you have sigmoid functions, you have ReLU, you have ELU coming up, you have leaky ReLU, you have tanh. These are all different types of step functions. Sorry, these are all different types of threshold functions. Just like our neurons have a step function, we can have different types of threshold functions. These are different types of threshold functions. Now, what's the best threshold function that you should be using? That's pretty advanced. That's kind of what you would do in optimization, machine learning optimization, model optimization job. You'll be using and trying different threshold functions. But the fundamental beautiful thing now in machine learning is you don't need to start these things from the scratch, because most of these things are already designed for you. So you don't need to, in fact, worry about all these things at the beginning when you are starting the career, because most of these things are already built in the packages that you will be using. If you use certain packages that we are going to show you today, most of these algorithms, most of these threshold functions are already inbuilt. You don't need to even worry about how these things works, because most of these things are already built in and it comes ready to be used. So to work on and to get your hands dirty with machine learning, you don't need to learn all these type of threshold functions. Don't worry about these threshold functions at the beginning, but start using them and start solving some problems and get into these things. And then you will see, how can I optimize this? At that point, come back to this and see, what if instead of a step function, what if I use a ReLU model? What if I use a leaky ReLU? That's the point of optimization. Only at that point, let's come back to this level. But this is for you to know and to, kind of appreciate that there are things called threshold functions that can work with different models. Right. That is about the default threshold function and how a typical neuron would work. Here's an example of how a threshold function works. And we are going to learn about one of the fundamental algorithms now. I told you, I promised you that today you are going to learn a classification model. So we are going to learn, in fact, a classification model, which is called the perceptron learning algorithm. So we are going to learn a very basic fundamental machine learning model today. This is a classification model. It is basically, we are going to basically talk about a binary classification model using a step function like this. I mean, this is the way a step function can be defined. And what we are going to do is, when you have a data set, look at this data set. You can see red color data and also blue color data. And we are going to see if we can classify this data set into two different segments, whether we can draw this line that will put this data into two classes, red class and the blue class. So ideally, this is what a perceptron would do. A perceptron will classify a class into two different segments. It's a binary classification model, but perceptron has multiple other advanced perceptron algorithms which can even go up to multi-class classification. But for this class, for this session, we are only talking about binary classification, only using binary or two-class classification. We are going to classify the data into two classes today. All right, I think you are still with me. So we are going to use the perceptron algorithm, and we are trying to classify some data into two classes, and we are going to do that today. And the name of the algorithm, or the name of the model that we are going to use, is called perceptron. If you're still with me, if you want to learn perceptron algorithm, type perceptron on the chat box. Type perceptron on the chat box, and the moment you start typing perceptron, you are going to learn what perceptron algorithm is going to do. Brilliant. So today you are going to be awesome. You are going to learn a lot. You are going to have a lot of fun, because now we are ready to learn our first and very most machine learning classification model algorithm. And when you know classification perceptron model, you will be able to do a fantastic work, because you know and you can classify data into two classes. So let's see what perceptron model does. Before really showing you code of mathematical forms of showing perceptron model, let me show what happens in fact in the perceptron algorithm. This is what we are going to do. In perceptron algorithm, this is what we are going to do. Initially, you remember our weights, right? Initially, we are going to put all weights to be 0 or a small random number. We are not going to put them into 0, but we are going to assign a small random number. A small random number will be assigned to each weight. Remember W, the W, the W will be always, the W will be always the weight, and weight will be here initially a random number. We are going to assign some small random number to each W. That will be our weight. And then we are going to get the features for each training example. Remember the words now. We were talking about training example. So we get our first training example and we compute the output. So we have two things now. We have the random numbers, which is the weight. And then we are going to, using that random weight, we are going to calculate the output for the first training example, right? And from that training example, since this is a supervised learning, we know the predicted value and we know the actual value. And using that, we are going to use these two details and to improve the weights or update the weights. So using that, we calculate the weights again, reapply the weights. We do that again as a cycle. So you calculate the weights, apply the weights, calculate the output again. Using the output, you recalculate the weights, do the weights again. You do that again. So you do it again and again and again and again. How many times? How many times depends on your problem. That's called convergence. Convergence is how many times you need to do until you come to a level where you are comfortable or where this system is doing good enough. That is called convergence. Convergence, again, in a very simple term, convergence means how many times you should repeat this process until you have a good enough solution. If the data is good enough for you, then you stop. That's called convergence. Convergence means then the system is good enough and it is predicting good enough. Until such time, you have to do this again and again and again and again. But there's a little catch to the perceptron algorithm. Remember, the convergence will only happen. It is only guaranteed if the two classes that we are talking are linearly separable. Linearly separable. What is linearly separable? That's a good term to listen. Listen, I mean, think about it. This is linearly separable. The first one is linearly separable set of data. See, the red color are on the left side, the blue color on the right side, and you can draw a line and separate them into two classes. That's what we call a linearly separable data. So if you want to apply perceptron algorithm, remember this. If you want to apply perceptron algorithm, you have to make sure that your data are linearly separable. Okay, your data should be linearly separable. If your data is not linearly separable, perceptron algorithm cannot be directly applied. But there are advanced versions of perceptron algorithm which can be applied to non-linear data as well. I mean, the second one, second detail, the second image, you can see it's not linearly separable. You can't draw a direct line to separate the classes. You can't. And if you think about the third line, you can draw a circle, but you can't draw a line because that even the third one is not linearly separable. But as I said, although the primary perceptron algorithm cannot work on non-linear data sets, there are advanced models, that there are advanced perceptron algorithms to work with non-linear data as well. But for the moment, remember, we are talking about linearly separable data sets to apply the first algorithm that we are talking about. So this is called perceptron algorithm, and we are going to apply the perceptron algorithm to a known data set, which is a flower data set. Right, now we are ready and we have a few minutes remaining, and now what we are going to do is to get our hands dirty, to get into the real work, to work with a real data set, to train a real data set, get some real outputs, and to apply the perceptron algorithm using a real data set. How many of you are excited to get things actually done, get some grease, get some mud into your thing? So roll up your sleeves and get ready to get things into really actionable state. If you're ready to go into the programming board and to start programming and to get these things into action, type yes and I'm ready. Type I'm ready if you're ready to see this in action, so that let's move on to our real programming board and get our first program or the first machine learning classification model ready and running. Brilliant. Thank you very much for your enthusiasm. Let me stop sharing my presentation and let me jump to our program. All right, let's see how our program is going to do. Brilliant. Now, before we are going to talk about the program, you may need to know what kind of tools you may need to run this kind of a machine learning model. Maybe you have heard of terms like TensorFlow. Do I need to install TensorFlow? Do I need to install GPU-based computer? Do I need to have GPUs with my computer? Do I need to have a lot of computing power? Do I need to have the latest version of Python? Do I need to have image processing software, or do I need to have knowledge about open source other software platforms? The answer is, guess it. You don't need to have anything. You don't need to install anything. You don't need to install Python. You don't need to install TensorFlow. In order to start this, you don't need to install anything at all. Are you excited? If you were thinking, oh, machine learning is going to be so difficult, I'm going to install TensorFlow, it's difficult. Installing TensorFlow, it's difficult. Installing machine learning things are difficult. Python is difficult. If you are thinking now that machine learning is a complete difficult thing, I'm going to tell you, it's going to be fun, because you're not going to install anything, because you are going to use some of the existing things which are absolutely good and cool. And if you are so happy about that, because you are not going to install anything at all and you're going to use any computer that you can use, and if you're excited about that, type yes into your chat box, because you are not going to install anything. And all the source code that we are going to use today, all the programs that we are going to use today, are using an existing platform called Google Colab. Here it is. Google Colab is a brilliant learning platform given by Google. It's shareable, and everything related to machine learning can be typed, can be coded, can be executed on the Google Colab platform. It's a simple workbook where you can prototype all of your machine learning related things. You can work with artificial intelligence type of things. You can create neural networks. You can go deep learning and create all of these things on the Google Colab platform. You don't need to install anything, my friends. You don't need to have GPU machines, because Google is giving you GPUs for free. You can use GPUs of Google for this, and it's giving you a lot of things. It's giving you a lot of RAM, it's giving you a lot of disks, it's giving you a lot of GPU space, and it's giving you Python, it's giving you runtime to execute all these things, documentation capability. And this is fantastic, because if you are starting, if you are new to this form of machine learning, you don't need to worry about all the other problems and difficulties and challenges, and you can only worry about how to learn things. It's pretty simple. You just need to worry about your Python, because I'm generally saying it's better for you to know Python as a language. Python is pretty straightforward. Python is pretty good to learn. So I'm going to invite you to learn Python as much as possible, because Python is pretty important for you to learn if you want to grow in machine learning. So if I can give you one advice, if you want to grow in machine learning, the advice is learn Python. Python is important. Python is really important. So I want all of you to type Python is important. Type Python is important. Python is a programming language, a cool programming language, a live programming language, a language that has a lot of support. So type Python is important. Python is really important. So if you want to get into the domain of machine learning, remember Python is pretty important. You need to learn Python, and this is kind of the first step that you have to put towards machine learning. I'm not saying that other languages cannot be used for machine learning, but Python is much more important and much more faster. Let's see some examples of how you can use perceptron algorithm. In fact, what we are going to do is the moment we finish this course, we are going to send you some emails. First email that you're going to listen or that you're going to receive is the the worksheet that I'm working, the very worksheet that I'm working. You will get this access to this, so you don't need to even worry about creating your own Google Colab flat platform just because we are nice, just because American Center is nice. We are going to share all this data with you, so you will be getting access to this exact worksheet, and you'll be able to run all these things by yourself. By all means, make sure that you can make copies of this, use these things. So let me elaborate what I have done here, so you'll be able to use these things at your own discretion, or you may be able to use these things personally. So this is what I have done. At the beginning, I have imported some Python existing modules. So this is the reason I say Python is cool. I mean, look at this. I have used something called pandas. It's a Python library, and I have something called NumPy. It's another Python library. See, Python is filled with these kind of modules and libraries which are already built. And the other part is Python is free. It's open source. And all these things, all these libraries are freely available. And because of that, most of the world, members, most of the people are using Python just to improve on these things. So use Python and use these modules. So I have used initially two modules, pandas and NumPy. Those are two libraries that I'm using for the moment. Then here is my perceptron algorithm. Now, don't worry what I have written. In fact, I didn't write this. I used already available perceptron algorithm from this place. If you are interested, you can go there and read that. This is the fantastic thing. You don't have to always start from the scratch and build your own programs. If you can do that, that's fantastic, but you don't need to do that at the beginning. See, what I have done is I have just used the perceptron algorithm just for the, just to save time. So now I have my perceptron algorithm. Now, the beauty of Google Colab is you can see that there's a little mark here. I can just click on that, and that particular section will be executed. Where will it be executed? Will it be executed on my computer? No, it will be executed on Google's computers. So it's fun. All these things are going to be executed on Google's computers. Let me execute my second one, which is my perceptron algorithms. You see, I click on this, and it's going to take just few milliseconds, and now that section is computed. It's now ready. So now this section is ready. And let's go into the next section. Now my perceptron algorithm is ready, and it's now in the Google things. And now it's another way. And now we are ready to apply our perceptron algorithm. Remember, we talked about our flower dataset. Let's talk about that flower dataset. That flower dataset is a freely available dataset. It's available in this link. When you get access to this link, this worksheet, you will be able to download this dataset. What I have done is I have used the URL itself, and I am getting this data from this URL. So I'm going to use this URL, download this data, and I'm going to show you what are the details of this data. Let me run that. Here I run that. See, it didn't take a lot of time because the resources of my personal computer are not used because it's processed at the Google's computers. So let's see what this data contains. This data set contains four things. Can you see here? It has four things, actually five things. It's the exact same data set that I showed you. It has something called the sepal length. It has something called sepal width. There are 150 samples, by the way, and there's something called petal length, petal width, and there's something called iris class. Iris is the family of the flowers. So we are talking about iris flowers, right? We talked that there are three types of iris flowers, right? There are three types of iris flowers. Let's see some of the data in this data set. So what you have to do is type this sentence, dataset.head6. That means show me the first 6 data of this dataset. Here I run this. Here it is, pretty simple. Here are the first 6 data of the 6 data sets. Let's look at that. All right, the first data. Here's the sepal length, here's the sepal width, here's the petal length, here's the petal width, and here's the class. It's a iris setosa type. It's a setosa type. I told you that there are 3 different classes. First one is setosa. So first 6 things are setosa type. If you want to see first 10 things, let's type 10 here and let's run that. Here it is. You have the first 10 things. You have all setosa things there. So first things are mostly setosa. Brilliant. Now I'd like to visually see this data set. But now, since I said our perceptron algorithm is just a binary classification model, it can only do 2 things. Although there are 3 types of families, let's select only 2 types of classes. So for this exercise, I'm going to use only setosa class and versicolor class. Remember, I told that there are 3 types, 3 families of flowers, but here I'm going to use only 2 types, only 2 families of things. I'm going to only use setosa and I'm going to use versicolor. And also I'm going to use only 2 features. Although there are 4 features, I'm going to use only 2 features. What are the features I'm going to use? The sepal length and the petal length. So I'm going to use only sepal length and the petal length as the features. And there are only 2 classes, 2 features. Let's visually see how these things look like. Here I ran this code. This is our visual representation. Brilliant, brilliant, brilliant. On the left-hand side, you have the sepal length. On the vertical axis, you have the petal length. And the red color things are setosa flowers. And the blue color crosses are versicolor flowers. Now, how many of you think that this data set is linearly separable? If you think this is linearly separable, type yes. Let's see whether you understood the question. So if you understood the question, if you think this is linearly separable, type that. Brilliant, 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 brilliant. So we have a set of data which is linearly separable. So this is something that we can definitely apply our perceptron algorithm. So why should we wait? Let's go ahead and apply our first perceptron algorithm. We are using something called epoch here. An epoch, it's a technical term. An epoch is this. You get your model, remember you get your model, remember your roadmap, you get your model and apply all the data into the model and see how is it working now. Is it better? Remember we applied all the data just once. That's one epoch. And if you see the model is not doing great, you get the data, you update the weights, you get the full data set again, apply all the data again for the second time. That's called the second epoch. If it is not still converged, if the model is still not doing good, you get all the data, test data, and apply all the data again to the model. Third epoch. Likewise, every time you apply all the available test data, that's an epoch. So how many times would you like to run this? That depends on your model. Here is my function. Remember earlier I showed you at the top, I showed you a function called perceptron. That's the perceptron algorithm. So I'm talking to that call and I'm giving 2 things called the ETA, that's eta, or that's called the learning rate, how fast this algorithm should be learning. I have mentioned that as 0.1. Don't worry about these numbers for the moment, but I have mentioned a very small learning rate at the moment. You can increase the learning rate and see what's going to happen. You can decrease the learning rate and see what's going to happen. And an n iter here means my epoch. How many epochs should we run this? For the moment, I have said only 10. Let's see if 10 is enough. And this program will fit. Remember fitting? Remember training? This function will train our model for 10 times. So let me run this. Here it is. Now it is running. Voila! We get the answer. Here's a visual representation. This is our 10 runs, and you can see that the vertical axis is how many errors is it happening. Is it getting better or is it getting worse? You can see at the beginning, the number of updates are getting increased. That's saying the system is still learning. So you can see at the epoch number 2, the system is still learning. The system is still learning. But at epoch number 4, the learning rate or the number of updates that are happening are getting slightly less. And at epoch 6, you can see it has come drastically down. The number of updates are not much. It's closer to 0. And after 6, you can see it stays low at 0, almost 0, which means it has converged. I'll show you something here, something cool. Let me update the number of epochs to 100 and let's see what happens. Okay, brilliant. You can still see in the picture that after close to 6 and up to 100, it stays low, which means at 6, it is converging to the number that we want. And so 10 seems good enough. If you run the algorithm for 10 times, 10 epochs, the system has learned perfectly to classify the dataset into 2 classes. Now our machine learning algorithm is built and trained to classify the model into 2 classes. Let's see the classified model. So I have written a basic simple algorithm to visually represent. Let me run this and we'll use this in the next section. So next section is to visually see the 2 decision regions. Are you ready? This is pretty exciting. Let me visually show you the 2 classes. Here it comes. We have done it. We have done it. We have taken our 2 linearly separable classes and found the linear classification model to separate these 2 classes. Now, if you get a new feature, you can easily apply this model and see whether that is a red color flower or a blue color flower. Congratulations, ladies and gentlemen. Now you have learned your first binary classification model, and congratulations to every one of you. And just if you enjoy the first perceptron algorithm, which is a binary classification model, and if you learned how that works, if you were clear about that, type brilliant. Just type brilliant. Just type brilliant on the chat, just to know that you enjoyed this, and now you know how to apply binary classification onto a real data set. Now we know how to get real data set, how to apply binary classification, and just in 2 hours you learned how to apply binary classification onto a real problem, and now you know how to classify a real problem into 2 sections. Brilliant, brilliant, brilliant. And thank you very much for your interaction. We have done a lot of work today. We have done absolutely great work today. We started with learning about learning about multiple types of classification, and we started learning about different ways of classification, and we started learning about different things about classification, and we learned about different applications about classification, and we talked about different ways how people can use machine learning, and we talked about the different types like classification model, regression model, and we started talking about neural network, and we learned how neural networks can be used in a real dilemma. We talked about how neurons work, and then we talked about the perceptron, which is our first algorithm, and then we started talking about the perceptron in action, and we have now come up to a stage where we learned about the first binary classification model. So far we have talked about a lot of things. So thank you very much for staying. Now we'll take some of your questions to see if we can answer in a very quick time frame. So let me go into some of the questions. Nadi has been
Yes.
so helping me capturing all the questions. So Nadi, let's probably rephrase some of the questions that we have got.
Yes. Here having one question is
Yeah.
one student asking from us. Machine learning is a statistical module.
Well, statistics always has a
Is that a
certain
statistical module?
right. Statistics always has a play that comes to machine learning. So I would say something like this. Now, machine learning is kind of an interesting field. It's filled with multiple science fields, multiple sciences. It's filled with it's enriched with biology, it's enriched with data science, it's enriched with statistics, it is coming with statistical models, but it doesn't need to be statistical model. It's sometimes coming with other models as well. So the direct answer is no, it is not always statistics, but it is enriched with statistics. So it's much more closer to that. If you know statistics, you may learn this faster. So it's pretty important. So the direct answer for that is don't expect that is to be directly work with statistics. And if you know statistics, that will be pretty important. And that opens me to answer another question, whether should you have a mathematics background to know about machine learning, or to learn or persevere about machine learning. My direct answer is kind of yes, because uh, because machine learning in fact in its essence is kind of mathematically driven. So if you have a mathematics background, it will be a plus point to you. But to start, don't worry if you have a mathematics background or not. You don't need a complex background to start. So start it somewhere, just like we started today, and it will be helpful for you. Right, Nadi, what's our next question?
Um, One request from us. We can upload whether we have to check whether we can upload this session into YouTube.
Sure, sure.
Yeah. Is business analytic part of machine learning? One
Oh,
question,
brilliant
important
question.
question, I guess.
Brilliant question. Absolutely brilliant question. I would say business analytics, or business analytics itself is one core part of any problem solving. The use of machine learning is just one solution, but the analytics are pretty important. Only by analytics you gain the initial insights to the problem, because any business process is started with business analytics. It doesn't need to be even machine learning. You talk about any business process, generally the process is initiated by business analytics. If you go to industry, you may learn that there are different set of specialized people called business analysts. Their job is to do the analytics first, to learn the problem, to understand the problem. So business analytics is pretty important. And even in machine learning, for the sake of serving time, I would say business analytics play a key role, a major role in machine learning. So if you have an idea of becoming a business analytics, I would say kudos to you. Learn business analytics as well as learn machine learning. It's going to give you more capability in terms of a business analysts. So you don't need to become a mathematician, you don't need to become a machine learning expert, but even if you want to become a business analyst, if you have a machine learning background, that gives you a lot of edge. So if you want to get a lot of edge, you need to have a business analytics background also, because it gives you a lot of courage, lot of I'd say a lot of concrete background. So fundamentals are important, as well as business analytics is just a part of machine learning. Nadi, I think you also can add something to that.
Yes, actually, machine learning analytic part mostly doing with using machine learning part, right? Analytic part is going with the deep learning and other things. It's like it's going together always. It's like
Brilliant, yes.
para. We always want machine learning for business analytics. It's going so parallel. So without machine learning, we can't do business analysis. Analysis part is always going with machine learning.
Brilliant. Very good answer, yes, Nadi. Yeah. So yes,
Yes.
I like that part. So it's going vice versa. You need this to survive the other one. You need the other one to survive this one. Brilliant. All right, Nadi,
Audience,
let's go to
very
the next
very
one.
important things. Most biology people doesn't like mathematics part. Mathematics people don't like
Good
biological
question.
part. I don't like biology. That's why I have chosen engineering.
Okay.
As far as neurology is concerned, it seems learn biology.
Very good question. Whoever poses this question, I think this question should have come when we were talking about neurons. But I'll go back to again to that question, my friend. If you are thinking on this, By any means, you don't need to learn biology here, but this is just to see that machine learning is inspired by biology, by the knowledge of biology, the neurons, the cells, how brain works. It's inspired by that. So you don't need to learn biology. You don't need to worry about biology, but this subject is brilliant and this subject is inspired by biology, I would say. So don't worry about whether you'll have to learn that thing again. No, don't worry about that. But this is all about enjoying what you love most. So I would say very simply, love what you want to learn. It's all about your passion, my friend. If you love engineering, keep loving it. It's a beautiful field. But even if you are, even if you love biology, still you can become a machine learning person, a machine learning expert. So there's no need for you to learn biology to move forward machine learning, but it is enriched with biology, I would say. Thank you for that question, by the way. It's a very valid question. Thank you, Nadi.
Another question from audience. So
Right.
neural network and machine learning gets more effective and accurate at making decisions with more good data we feed. But they can be unpredictable situation. How it can be confident to adapt to a situation.
All right. This is what we call importance of data. See, we talked about pre-production of data or pre-processing of data. So you get data and you pre-process this data. This is the general time that you talk about, classifying the data into two things. You generally get training data and then you get some data to test this data. And sometimes these data are adaptable, predictable, and sometimes not predictable. So what you do is you don't always depend on predictable data, but you want to add some unpredictable data also. Otherwise, you have a bias towards the data. In order to avoid the bias, what you do is you mix the data with predictable data, unpredictable data, and try with all the available data. So you don't bias your training model. Otherwise, what happens is if you have more predictable data, your model will be more biased toward that predictable data. And you don't want that biasness from your models. So what you do is you get your general data and you break that data into two parts called the training data and the testing data. What you do is at the training time, you feed only the training data to the model and you never ever test your model with the training data, but you use your testing data to test the data. Remember that. That is very important. Even when you read the workshop, the details or the worksheet, you will see that we have used only 100 data. The rest of the 50 data are reserved for testing data. So that's one way how to handle predictable and unpredictable data. You generally mix all of these things and train with collection and test with the collection. So you don't want to bias your data with only predictable data. But by all means, I can say if there are unpredictable data, that's better. That's a sign that you can improve your data, improve your model, because you always want unpredictable data. Otherwise, if you always have predictable data, your model will be brilliantly good, always good. But the moment it is hit with the unpredictable data, the model is going to collapse. You don't want that to happen. Because of that, what you do is you build upon both predictable data and unpredictable data. Put them together, train it. Put them together, train it. That's how you just do when actually you do the system. Any more questions?
Yes. Last question from audience.
Yeah,
What are the
Nadi.
best sources for self-learning? I think we have
Oh,
done the
right.
best source.
Brilliant. That's a very good question. Now, I think American Center is doing a brilliant job here by giving you this first opportunity. So I think they deserve a round of applause. So here's a round of applause from me for giving this free opportunity to the Sri Lankan kids and Sri Lankan students and the working people, undergrads, to learn these things, to at least lay the foundation for this. So this is a very good starting point. And there are a lot of good recommendations of books you can search, which are freely available sometimes. There are a lot of courses available, Coursera modules available. In fact, we are thinking about giving you a gift based on your performance of some of the assignments that we are going to give you. Wait for that, because there are some brilliant gifts and presents ready to be given to you. There will be some of the self-learning modules which are expensive, and we are going to sometimes give that and offer to you free of charge based on your performance. So make sure that you start working with some of the emails that we are going to send you. We are going to send you some homework, and some of the brilliant homeworks will get some presents. We're not going to reveal it at the moment, but how many of you like gifts? How many of you like gifts? If you like gifts, type yes on the chat box. If you like gifts, type yes on the chat box. Let's see how many of you like gifts. Brilliant, you like gifts. Thank you very much. Thank you very much. So what we are trying to give you is, we are going to probably give you some of the cool gifts by how much of you are working with us, how much you are interacting with us, and how many of you are working with the homework that we are going to give you right after this session. And there will be cool gifts, which are learning resources, by the way. And if you are interested in self-learning, there are a lot of books, there are a lot of courses freely available. And if you are ready to spend some money, there are Coursera courses which are paid courses, as well as there are very popular Coursera and other learning platform courses available on machine learning. Please make sure that you use the fundamental knowledge, and these are very fundamental, and you can start from the basics. You don't need to have a huge mathematics background or huge Python background. You can start always from a course. But I would say start learning Python. That is very important. And start reading as much as possible. Start reading a lot of books. And there are a lot of blogs which are providing free resources. We can also recommend some of those things and some books. And please start reading these things. And I have denoted some books in our course worksheet also. You can read that book. Basically, it's a collection of some examples. Some example source codes are also there. A book is also there. So make sure you start self-learning as much as possible, as early as possible. And it's the best way to learn the art of machine learning. I believe that's the end of the question. So thank you very much, Nadi. Before I hand this over to our fantastic panel of Makerspace community, I would like to thank you, every one of you, for staying here so far. I know this is a Sunday night, but look at here. Almost all of you are still here listening to me, and you are all fantastic. Before we wind up, I want all of you to give a thumbs up to the American Center, the Makerspace community. So say yes and say thank you to the American Center, to the wonderful organizers of this program. Say thank you, and thank you to all these people. Give a thumbs up, give a thank you, send some love to all these people. And I, from the bottom of my heart, say thank you for all of you, for being here, for interacting, for being fun, for showing eagerness. So thank you very much for being here and showing your energy. Thank you very much for giving me energy. Unless you give me energy, I will not be able to deliver with this energy. So thank you very much for giving me energy. And I'm going to see you again in 2 weeks' time. Until that time, make sure that you are always linked to our emails. Make sure that you read emails. The WhatsApp group is there. Make sure that you interact. Thank you very much so far being alive. Make sure that you follow the emails that are coming up. There will be a lot of emails coming in and giving you more details. And with that note, please stay safe. And until we meet again, thank you very much. Stay cool and make sure that you have fun in all the endeavors that you do. Thank you, Ranjan. Thank you, Nadi. The control goes back to you.
Thank you so much, Silna. It was great session today. I think our audience enjoyed so much from you. Actually, this is great session. Thank you so much, Silna. I think today's session we are going to wind up now. Thank you so much for being part of us.